Okay, welcome to the 5-4 Concept Guide, our lesson on special quadrilaterals. Actually, let's call them special parallelograms, because that's what they really are. I'm sorry about the lighting in here. Hopefully everybody can see okay. Rectangles, rhombuses, and squares are special types of quadrilaterals. They are, but that's because they're special types of parallelograms. They're even more special than special quadrilaterals. They each have special qualities, and they each have the qualities of parallelograms. So a quick review of the qualities of parallelograms, which each of these things, rectangles, rhombuses, and squares, each have. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other, and consecutive angles are supplementary. That should all sound familiar, because we already know those things about parallelograms. But when we're talking about rectangles, rhombuses, and squares, we have those same qualities. Now, rectangles. You've known about rectangles for a really long time. You know that rectangles have 4 right angles. Yeah, they still do. But that's what makes a rectangle a special parallelogram. It's the only type of parallelogram that has right angles. Also, you may already knew this, Mark may already have known this, but rectangles also have congruent diagonals. So in this rectangle over here, ABCD, diagonal AC is congruent with diagonal BD. And that's the case for every rectangle. Now, let's go ahead and just talk about this for a second. If we have a rectangle, which of course it has congruent opposite sides, and then all the angles are right angles, every single one of these triangles that we draw from using 2 sides and a rectangle, they will all be congruent to one another. If a parallelogram has 1 right angle, well, then the parallelogram has 4 right angles, and therefore it is a rectangle. You cannot have a parallelogram with only 1 right angle. It will have 4 of them if it's got 1 of them. All right, on to rhombuses. Rhombuses are parallelograms that have 4 congruent sides. That is what makes a rhombus a rhombus. It's a parallelogram with 4 congruent sides. Some other things about rhombuses have to do with their diagonals. The diagonals of a rhombus are perpendicular. That is special to rhombuses. They're the only types of parallelograms that have perpendicular bisectors. They also have another quality, that diagonals of a rhombus bisect the angles of the rhombus. So, as you can see, what I've just done, of course, the opposite angles of a rhombus are congruent. So, if these opposite angles are congruent, then it creates a whole bunch of smaller congruent angles, 2 different sets of them. So let's do the same little talk about what a rhombus will do with its diagonals. It won't create 4 congruent triangles, but it will create 2 sets of isosceles. You can see the red one that came up here along with the pink one are 2 congruent isosceles triangles. That's different than the rectangle ones. And if we use the other diagonal, it'll create 2 other isosceles congruent triangles. So that is what's special about rhombuses: 4 congruent sides, diagonals that are perpendicular, and diagonals that bisect the angles. On to squares. Squares are parallelograms, rectangles, and rhombuses. They're like super parallelograms that have all the qualities of all of these things. So squares have congruent sides, angles that are congruent, angles that are all 90 degrees, diagonals that bisect each other, diagonals that are congruent, diagonals that form 90-degree angles, diagonals that bisect the other angles. All of the qualities of parallelograms, rectangles, and rhombuses a square has. And you thought squares were simple creatures. Also, it's worth noting that diagonals, or squares, have diagonals that bisect as 90-degree angles, creating 45-degree angles. So every small angle there on a square that's broken down by the diagonals creates 45-degree angles. So we end up with a bunch of triangles that are all congruent, where all the angles are 90, 45, and 45. And those are very special triangles that we'll be talking a lot about as the year goes on. So squares are awesome. Okay, so that is the deal with these three special types of parallelograms: rectangles, rhombuses, and squares. Now, our book doesn't talk much about these things, but it's worth, when we're talking about special quadrilaterals, this needs to go in here somewhere. A kite is not a parallelogram. Let's just get that straight, but I'm just throwing it in here with these other parallelograms. A kite is not a parallelogram, but it is a very special quadrilateral. It has some couple of qualities that are worth noting. It has two pairs of congruent sides, which you've built kites probably before, or at least played with them, or drawn them, or seen them or somewhere, and you knew that about kites. But did you know that it has diagonals that are perpendicular? Now, there's one more related theorem in this section that we need to address. And I'll explain to you here in a second why it's in this section. But let's go ahead and describe it to you. The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. Now, you may be saying, wait a second, what is a hypotenuse? And let me define that for you here momentarily. This is a word that we're going to be using more and more and more as time goes on. But a hypotenuse, if you look at this triangle that I drew over here, the hypotenuse is the long side of a right triangle. It's always going to be the longest side, and it's always going to be the one that is opposite the 90-degree angle. That has a special name called the hypotenuse. Now, back to our theorem. So the midpoint of the hypotenuse of a right triangle is equidistant, has the same distance from each of the three vertices. So that midpoint x of the hypotenuse AC over there is therefore has the same distance from A as it does B and C, the three vertices of that right triangle. So the segments AX, XC, and BX all are congruent. BX is the median of the right triangle ABC. If you remember what the definition of the median is, it's a segment that goes from the vertex, in this case it's the right angle vertex B, to the opposite side, the opposite midpoint, which in this case is X. Now, why does this theorem show up in this strange place in the middle of all these special quadrilaterals and parallelograms? Well, what is a right triangle? Well, a right triangle can be described as half of a rectangle. If you take a rectangle and chop it in half via a diagonal, well, you end up with a right angle. And then, of course, the diagonals of a rectangle are both congruent, and the diagonals of a parallelogram bisect each other. So what do you end up with? Well, if you look at that midpoint of what used to be our triangle, hypotenuse of that triangle X, that midpoint X is really the midpoint of this rectangle that I've drawn by filling in the other half of that triangle. So this related theorem is really kind of like half of a rectangle theorem, if you will. Okay, so we end up with some different types of questions. There ends up being a surprising number of questions that we can ask about squares and rectangles and rhombuses. But we're going to start off with these right here about the angles. The first part of these questions, I'm going to do the first couple here with you. Number one, it asks us to name the type of parallelogram that it is. Well, because all of the sides are congruent, this is a rhombus. Now, if it's a rhombus, what we know about it is the red triangle that I've drawn over here on the right hand side. It's an isosceles triangle with that diagonal. Or we also know that the angles of a rhombus, the diagonals bisect the angles. So what we have going on here is that angle 3 there is equal to the same as the given angle over there in 54, which is going to be the same as the angle over there 2. Now, how can we know that the other angle is 74? Well, the red triangle that I drew, 54 plus 54 plus 72, those are what equals 180. So to answer these questions, we have to think about sometimes isosceles triangles, the triangle theorem, the angles adding up to 180. Then we have to keep in mind the things we've just learned about diagonals and bisecting angles, etc. Number 2, you should be able to recognize that it's a rectangle because of the right angle that is given. Now, how to find what these angles are? Well, we need to keep in mind that we have alternate interior angles. This is a parallelogram. So that 18-degree angle that's given is the same as angle 3. And because it's a rectangle and a parallelogram, we have all sorts of places there, angles that are equal to 18 degrees. Now, because it's a rectangle, that 18-degree angle in the top right-hand corner and angle 1, those two angles are complementary. So angle 1 is going to equal 72 degrees. And so there's going to be a bunch of different angles there that are also equal to 72 degrees. There really ends up being a bunch of different ways you can go about answering these types of questions. I'll just mention a couple of ways here. We can know that angle 4 is equal to 144 degrees because there's a triangle down at the bottom. Angle 3 plus angle 4 plus that other angle 18, those things got to all add up to 180. So 180 minus 18, that's 144. And angle 4 and angle 2, those are supplementary, or we could use the triangle theorem again, or you can use, well, you get the idea. There's a bunch of different ways you can do this. Go ahead and try 3, 4, 5, and 6. Give those your best shot, and pause the video and come back for some answers. Okay, hopefully these things get a little bit easier as time goes on. We'll be doing some more practice here as well, but those are those questions. Down at the bottom, a couple of questions about rectangles. I think you'll find these a little bit happier if you didn't like the first set. But HIJK is a rectangle. There it is. And what do we know about HJ and IK? Well, there are diagonals, which because it's a rectangle, they are congruent. So that there is the key to solving 10, 11, 12, and 13. Give them a shot. Alright, here are the answers I got. I may have made a mistake. Hopefully I didn't. But compare those, and if you have questions about these, be prepared to ask them in class. Or get help from somebody else, of course. Alright, got a big day tomorrow. Get some rest.